LittleBits provides snap-together modules that have a common interface. You can do something very similar in software. Here is a simple way of doing software snap-together components. What I've done in this project is to define some basic software components, such as analog input 0, analog input analog 1 port, D5 analog out, D5 digital out, D9 analog out, and D9 digital out. I also have a power component, and so basically each of these software components is linked together by just calling the function one after the other. So for instance here I'm setting power 0, which sets stream 0, and so the analog 0 input is read and its output to D5 as an analog output. Stream 1 is set by power 1, reads analog input 1 and outputs to D9 as a digital output. So over here I have two dimmers, one on the analog 0 input and a bar graph on the D5 output, another dimmer on the analog 1 input and a bar graph on the D9. So this should be an analog output and this should be a digital output. So as I turn the dimmer up, you can see that the lights light in succession. On the other input, as I turn, nothing happens until it gets halfway and then instantly comes on. So this is basically a digital circuit using these things, and this circuit is an analog circuit. I've used the console port on the Arduino to output trace messages. Here you can see the trace messages being output by this program. What I'll do is I'll turn off the scrolling so it'll be easy to see what's going on. So the output here is stream 0, do power, and that basically outputs the number 1023. This is basically represents the maximum input voltage. Currently on stream 0 then we do an analog input on A0, which is returning the value 19, and on stream 0 we're doing a digital D5 analog output of the value 19. On stream 1 the power is set to 1023, so it's that initial value. On stream 1 we then do an analog 1 input, which currently has a value of 243, and on stream 1 we then do a D9 digital output of the value 243. Now 243 is obviously less than, so here we can see basically the information passing from one piece to the next. In the actual code I use a simple data array to hold one value, the current one value for each stream. So for instance the analog input A0, I just read the value into this current stream. Trace message will print out what we saw on the over here. Same thing with analog 1, A1. I read analog input 1 and write it to the current stream data. The output, D5 analog output, takes the current stream data, checks it's within the range, and then writes it out as an analog value. Now because the analog output is only 8 bits, 0 to 255, we have to divide 1023 max by 4, which is the same as shifting it right by 2. before we output it. Same thing with digital output. We compare the current data value with 512, which is halfway. If it's above halfway, we output a high. If it's below halfway, we output a low. Same thing now with D9, analog and digital. And here the power pseudo bit, because everything in LittleBits starts with a power bit. As long as the stream number is 0 to 9, we set the initial value to 1023, because the power bit data output is 5 volts. And there we have our software bits. Obviously we could add more software bits and add code here to provide more complicated functions, and we could emulate quite a lot of different things this way. You wouldn't necessarily do it this way, but this is an example of how software can be used to emulate hardware, and we use hardware to emulate software. So here I am adding some logic soft bits. So this is going to be the AND soft bit. It takes the input from the current stream and the input current value from the stream specified here and ANDs them together. To convert the current stream into a logical true or false, it compares it with 512, and the other stream it also compares with 512. If both of these are true, this is the AND logical AND function, then we're going to output 1023, otherwise we're going to output 0. This is the OR logical soft bit. It's going to take all the current stream with the specified stream data. So we're going to convert the analog input from 0 to 1023 into a true or false. So we compare it with 512, and the other value, stream value, we compare with 512. If this is greater than 512 or this is greater than 512, then we set the value to 1023, else we set it to 0. This is an invert soft bit. What we do is we subtract the current input value from 1023. So if the current input value is 0, we'll end up with 1023 as the output value. If the input value is 1023, we'll end up with 0. If its input current value is 512, we'll get 511. So basically this inverts the signal. So here I'm going to use two streams. Again, I'm going to use, on stream 0, I'm going to use the analog 0 input, and I'll output it to digital D5 as a digital output. On stream 1, I'm going to do the A1 input. I'm going to AND it with the value from stream 0 and output on the D9 digital output. So now I have two inputs. So I set that input high, and this input is also high. I set this one to low, set this one to low. So I make this one high, nothing happens. I make this one high as well, then this one also shows D9 is high on there and high on here. If either of them is low, nothing happens. Output is low. If both are high, I get the AND. So now let's show the OR function. So with the OR sensor, the OR bit, if either input is high, so I turn that one down to 0, turn this one down to 0, the D9, which is the OR of these two inputs, is output. If I turn up either one, or the other one, or both, then the output is a 1. So now what will happen once it's uploaded is that if either the input is high, then the output will be low. If both inputs are low, then the output will be high. So that's low, low, I get a high. If I make that one go high, the output goes low. If I make this one go high, the output goes low too. Now I can replace the dimmer with a switch, make it even more obvious.